that go. This lab is on solutions, ladies, and you have a variety of stations to get to, so be efficient. Anything marked with an asterisk, you can do later. Station 1, very simply, you're looking for the solutes and the solvents in here. Just write down what you see on the labels and read the directions. If there's more than one solute, list all of them. All right, that's station 1. You ready to go to station 2, Mrs. McGavin?
Yep.
Station 2 now has been moved to table 5. So we can use this overhead projector here. At station 2, you're comparing solutions to suspensions and colloids. And you have a list of properties that you filled in on the chart. As you know, when you're looking at a solution, you want to tell them this is a solution. When you're looking at solutions, you don't see any particles in there. They're so small you can see through them. But if you have a suspension or a colloid, there might be something called the Tyndall effect. So in this beaker, I have some clay. Are you close enough to see this? Clay and water. Clay-water mixture. And this is not one you will be looking at. But if you see a couple things, the particles are settling out in here. But if we put this on the light here from the projector and look up at the white paper on the wall, there's no light going through. The particles are blocking the light. But if you look at the bottom of the beaker, it looks like it's glowing because the light is being scattered by the particles, and that is what is known as the Tyndall effect. So that's one of the things you'll be looking for at this station, the Tyndall effect. Ooh. When you're done, please turn the projector off. Station 3 is at table 3. There's a lot of things to do here. And please, on all these stations where it talks about amounts of things, follow the directions. Except where I'm going to tell you right now something different. And I forgot to tell them over there. The colloids, again, your book says they're always heterogeneous. I think they can be either heterogeneous or homogeneous. All right, at this station you're looking at solubility, what types of things will dissolve in other types of things. So we have liquids, solids, and liquids, liquids and liquids. First of all, liquids. So it says to take 3 milliliters of water and put it into small test tubes. All right, we have a test tube here for comparison. Do not use this, just use it for comparison. At the mark where the tape is, the top of the tape is 3 milliliters. So just hold these other 2 test tubes next to that and put water approximately to that volume that you see on the tape. All right? And then you want to add to then you put some food coloring in, 1 drop in each. And then you will add hexane to one and ethanol to the other. Now this is where it says 3 milliliters of each. You really don't need to measure those 2 liquids carefully. In fact, we're running a little low on hexane, so just squirt a little hexane into one of them and squirt a little ethanol into the other. And then I believe it says stir with the stirring rod and see which one mixes and which one doesn't. All right. And then you will do a similar thing with water again, just with water in the 2 test tubes. And then it says a match head size amount of iodine in 1 test tube and a match head size amount of copper sulfate in the other. So the solids are here. Match head. You know what a match looks like. Just a little teeny tiny bit of this. If you use too much, you will not be able to tell what you are doing. And that's probably more than a match head right there. Like 3 match heads. So just a little tiny bit will work better. At the end of the table there are some models here which are to help you understand why things are dissolving as they are, and you want to try to remember things about polar and non-polar. That's a hint. When you're done with your test tubes, they get dumped into the waste beaker and just cleaned out really well with water and a
Yep.
Are we out of time? Oh.
No, we're good.
Station 4, that was 3, this is 4 right next to me at Station 4, Table 4. 2 parts to Station 4. Number 3 is on that side of the table, and then steps 4 and 5 are over here. In step 3, we've got 3 different flasks. They all have copper sulfate in them in the amount listed on your chart. So 11 grams was put in the first one in 100 grams of water, 20 grams in the next one, and so on down the chart. And if you understand the statement in number 2 about what do you need to make this saturated solution, you should be able to figure out the rest of the chart, but ask if you have questions. And then in steps 4 and 5, you will be getting from your teacher a test tube which has some super saturated solution of sodium acetate. Thank you, my lovely assistant. And you'll add 1 crystal of sodium acetate to this and see what happens. And compare this with what we have on the table. And your teacher will do this in your class probably to start with. In these hand warmers, the same substance is in here that was in the test tube I just had, sodium acetate and supersaturated solutions. These are both unactivated right now. We will activate one at the beginning of class and leave it here, and then leave the other one unactivated, please. Station 4. Station 5 is at table 2 since we switched 2 and 5. And here you're just looking at concentration, which you've been learning a lot about in class lately. So on the sides of the table are steps 2 through 4. Just write down what you see on the labels and answer the questions. And step 6 is at the end of the table. You see 3 flasks with different concentrations of potassium permanganate. And just answer question 6 when you look at those. All right, station 6 is a biggie. Conductivity of solutions. Why don't you come around on this side? All right, so on each side, we have the conductivity probe. So when you get here, it should be in a beaker labeled storage. You want to raise the clamp out of the beaker, storage beaker. Just lift it and then clamp it up. Put the storage beaker aside somewhere. You don't have to raise and lower this. Step 2, you do not need to do. It says place 40 milliliters of water in a beaker. It's already done. So we have beakers lined up here with all the things you're going to test. Distilled waters first. And all of these, when you go to test them, just put the beaker under the probe. Make sure the probe is in the liquid. Swirl it around a little. And then next to me is a calculator that has a reading on it. And you write down what that reading is off the calculator. This is a measurement, excuse me, in something called microsiemens. It's a measure of conductivity. If you have less than 200 microsiemens, since we're doing 200, right? 200 or less, you're going to call it a non-electrolyte, which you can record later, but you might want to make a note of that right now. In between tests, you really don't have to do this after the distilled water, but after all the others, in between you want to rinse the probe. There's a waste beaker, there's distilled water, just squirt some water around the edge here, and there's paper towel here. Take a piece of this toweling and dab off the end of the probe. Okay, and then go down the line and record the measurements. It says in step 5 to dry out the distilled water and so on. You can just leave all the beakers as they are, but when you're done, the probe needs to go back in the storage solution. The only difference between these two sides is this side has a computer instead of the calculator, and you will just get the reading once this is on. It'll just be right on the screen here, the reading that you need. Please keep the chemicals away from the computer. Keep everything to that end. All right, the last station that's actually in the lab is Station 7, Table 7. You're going to be looking at factors that affect the rate of dissolving. And this is in steps 2, 3, and 3. 2, 3, and 3. Actually, you know it. So, follow amounts again. Step 2, using a spatula, put 1 crystal of potassium permanganate in each of 2 test tubes. So KMnO4, potassium permanganate. Now, tip the little container